So let's plot the equation y equals 2x onto a Cartesian plane. Okay, so we've got our point there at 0, 5 would go to 10, and negative 5 would come down here to negative 10. Okay, and we can get a ruler out, so we're just plotting y equals 2x, and we'll pop that onto here very roughly like so. So that's my y equals 2x line. Now in this video, we're interested in perpendicular lines. Okay, so perpendicular lines are those lines which come off at 90 degrees to each other. So for example, this line here and say this line here would be perpendicular, or maybe this line here and this line here would be perpendicular. So we have to come off at right angles. So you can see all of these right angles which are existing in here. So some perpendicular lines, if we try and draw them to y equals 2x, and we'll do them in red. Okay, so we'll try and draw some perpendicular lines here. This line here would probably be perpendicular, so it's about a right angle. This one here looks pretty perpendicular. This one here, maybe this one here. You can draw as many as you want along that line. Okay, now what is the property which gives rise to perpendicular lines? Well, if I multiply the two gradients together, so the product of the gradients, so what I mean by that is if I take the gradient of this black line here and then this red line here, okay, those two gradients, if I multiply them together, then the product of them has to give me -1. So I can use that property to my advantage to work out what the gradient of that red line needs to be. Okay, so the product of the gradients, if I take the gradient of my long black line, y equals 2x, I know that that gradient is 2. Now I don't know what the gradient of the red line is. That's what it is that I'm trying to find. So we'll put that as m. Well, I know that if they're perpendicular, they have to multiply to give me -1. So I've now got an equation which I can solve for the gradient of my perpendicular red line, or my m there. So m is -1/2 in this case. So the gradient of all of these red lines, because all the red lines are parallel to each other, right? So the gradient of all of those red lines, m would be -1/2 for those red lines. And the gradient is 2 for our black line. So the product of the gradients has to give me -1 for perpendicular lines. Let's say that I want to pick the perpendicular line though, which goes through the point. So it has to go through the point, and it might be, let's say it's 2,8, for example. Okay, so I want the perpendicular line that goes through there. So if I find where that point 2,8 is, 1, 2, and 8 is all the way up here, okay, then it's probably going to be that red line that I've just drawn. Okay, so it has to be that one. It can't be any of the others. So how do I work out the equation for that? Well, I know that the equation of any linear line is mx plus c, but I've worked out that the gradient of all of those red lines is -1/2. And we work that out because they're perpendicular. They have to multiply by my 2 to give me -1. So I can just put this point 2,8 into here. So I get 8 is equal to -1/2 lots of 2 plus c. And you solve this equation, 8 is equal to -1 plus c, so c would have to be 9. Okay, and you can kind of see that because if I continued this line out a little bit further, we're going to see that we're going to go through that point up there at 9. So we've pretty much nailed that sketch. So there's infinitely many perpendicular lines that I can draw, but there's only one perpendicular line that is going to go through that yellow point there, which is my 2,8. So hopefully that makes some sense. We'll do another example now. Let's say that I want the equation of the perpendicular line that, so it has to be perpendicular to y equals -3x plus 4, and that has to go through the point 9, -6. Okay, so if it's perpendicular to y equals -3x plus 4, so we know that the equation of this line first of all is going to be mx plus c. But if it's perpendicular to -3x plus 4, then the two gradients have to multiply to give me -1. So the gradient of this line and the gradient of the line that I'm trying to find have to multiply to give me -1. So -3 times m has to be -1. So I can solve this equation and I get that m has to be 1/3. So the equation of my perpendicular line is going to have a gradient of a third, so 1/3x plus c. And now I want to work out, so I've gone, great, I know what the perpendicular line's gradient is, but I need to know how far up or down the y-axis to put it. Which one of these is it going to be, sort of thing? Is it going to be that one? Is it going to be that red one, or is it going to be that red one? And it has to be the one that goes through the point that's given. So it has to go through this point 9, -6. So we can substitute that point in. -6 is equal to 1/3 times 9 plus c. Okay, so we can solve this equation. 1/3 times 9 is just 3, so c would have to be -9 in this case. So we get that the equation of the perpendicular line would be 1/3x take 9. Okay, and that could sometimes be written as x on 3 minus 9. So that would be the equation of the linear line, which is perpendicular to that line there, and it goes through that point.